Hello everyone. This presentation is going to be on contemporary and future trends, which eventually going to talk about nanotechnology in architecture. This is going to be a complete view from a book which says about nanotechnology and its use in architecture. So firstly, what is nanotechnology exactly? So nanotechnology means dwarf. So in Latin and Greek, nano means nanus, so which have the meaning of dwarf. So these materials cannot be seen directly using our naked eye. Those are the particles which are called as nanoparticles, which are very tiniest particles. So the term nanotechnology was coined in 1974 in University of Tokyo in Japan, and you have the dimension which is like 10 to the power of minus 9 nanometers. So it is the quantity level which is compared or which is stated in nano material. So how does it work? Say you have a total surface area of 6 centimeter in 1 centimeter by 1 centimeter cube. And you are applying something on its surface. The surface is going to be 6 centimeters. So what happens if we are going to just cut the 6 centimeter cuboid into 1 mm cubes? So then we'll get 60 centimeter of the total surface area which can be covered up using the same amount of application. Say what happens if you're going to again break it down into 1 nanometer cubes. Then you will have a very good amount of total surface area, a complete crushed out total area in which you can apply whatever you need. So this is how the nano materials are used. So what happens is that the amount of material that is going to be used is going to be very tiny. So the effective use will get increased in nanomaterials. So again, this is used in aerospace, electronics, automotive, medical, food, and in environmental technology as well. So while we talk about architecture, we see a lot of materials where we need these kind of nanomaterials to have its impact, so that we can just get rid of a lot of issues that we face in architecture, in buildings in itself. So we have two kind of materials basically. One is the true material, where the honesty of the material which will be showcased as such. Whatever you see is what you get. The authenticity is the priority, and these materials will be the high quality materials. Then you have the fakes, where you have the artificial surfaces, which is going to be the imitation of the natural materials. So what happens here is you will get the same surface of the natural material, which is going to be of very low cost and easy to maintain and all those stuffs. But then the exact inside of the material will not be there. Then we have the third kind of material, where the nano particles is going to be used, and the nano surfaces will have both the external view as well as the internal quality of the original materials. So this is how nanotechnology is influencing architecture. The complete presentation is taken from Nanomaterials and Architecture, Interior Architecture and Design by Sylvia, Leydecker, and this particular book is having a lot of insight. So again, the author have published so many articles on nanotechnology. So this particular book was selected and it was used here. Here they have talked about few nanomaterials, and firstly, I'm just categorizing into two basic typology. One is cleaning and the other is solar control. If you take cleaning, we have a lot of pollution around. We have a lot of air pollution, especially because of a lot of carbon dioxide emission from vehicles, from industries, and so on. And we have a lot of odor as well. So to overcome all this, we need a very good material which is going to protect our building. So because these kind of pollution is not alone going to be harmful in human beings, that is going to affect the buildings as well. The lifespan of the building may get reduced because of the pollution. So these kind of nanomaterials is helpful. So the other side is that cleaning. Say you have a lot of high-rise buildings, you have a lot of glass which is used, you have a lot of pure white buildings to showcase what you want to show to the viewer. So in these kind of cases, cleaning might be a problem. When we have a lot of structures which is having a varied shape, so cleaning might be difficult. So self-cleaning ideology is being evolved because of this. And here what happens is, it doesn't mean you need not to clean the building at all, or the building just clean itself all time. The maintenance time between normal in the which is used in normal building can be prolonged a little bit, which will help the maintenance cost to get reduced. So here lotus effect, photocatalyst and easy to clean are three different categories which are shown here. And the next is the solar control. We need a lot of sunlight inside a building, but then it is not the building have to get heated up. We need a clear vision. We need glass to let view and lighting inside a building, but then we have to get protected from UV rays entering inside the building, and also the temperature change. Because of glass, heat it should not get increased, and the cold should not get blocked while we use other materials. So these kind of things can be done using solar control by nanomaterials. Then we have other materials which is again for air purifying. Fragrance capsules. These capsules will act releasing the pressure, or releasing its fragrance using pressure. Then we have fireproofing, which will be a very lighter material to have fireproofing in your glass and other materials. Then we have anti-fogging. Anti-fogging, especially in your cars, in your bathrooms, in your mirrors, where you'll have a change of temperature in and out, so that the fog will get loaded on your surface. Then is anti-reflective. When you have a lot of glass in your building, when you have reflective surface on your exterior, you will have a lot of reflection happening. So to cut down the reflection and to increase the amount of or the efficiency of lighting inside, you need anti-reflective coatings. Again, anti-fingerprints. So we have a lot of steel, or we have metals or any other glass material, where if we have fingerprint in normal criteria, you will have the friction happening between our hands and the surface, where the fingerprints will just get sticked onto the surface. That can be again avoided. Then you have anti-graffiti. Anti-graffiti is again a problem, where you have a lot of public buildings, and the graffiti effect have to be reduced, and the building have to last long with its actual beauty. So that anti-graffiti is essential. Then is antibacterial. These antibacterial materials are very, very effective in hospitality side, whereas both in the pure hospitals, where you need to take care of the infections out of your space, like hospitals or special cares, and even in hotels where you have a lot of people coming in, and the bacterial infection have to be get rid of your spaces. Then you have the scratch proof and abrasion resistant. So what happens here is every material will have friction. When surfaces are in contact to each other, you will have friction happening. So while you have friction, again it is going to scratch your surface. So that can be again avoided using nanomaterials. So first we'll see in detail about the cleaning materials. So first is self-cleaning. lotus effect material. So what happens in a lotus leaf? We can see droplets of water on the surface of lotus, but then it is not as a thin film, not as a thin film of water. It is just remains as either big droplets or very, very tiny droplets or dots. So these are possible because of the microscopically rough texture of the lotus. So it has very rough texture when we see the leaf structure through microscopes. So because of that, it is going to be hydrophobic, and the water just run off. So this is again used in nanotechnology. So what happens is that in lotus effect, if we use the nanomaterial on the surfaces, while the dust is getting deposited, while the surface again is exposed to water or rain, the dust will get carried away by the droplets of water. So once the water hits, it is going to carry away all the dust and just cleans your surface. Then is photocatalysis. So this is again hydrophilic. Here we need UV light in addition to the water. UV light is going to broke the dust into loose particles, and the water is going to just take away the dirt along with the water. Then is easy to clean. So easy to clean is the very, very smooth surface where the surface attraction will get reduced by itself. Then the water, when it is going to run off, it just takes off the dust along with that. Here you don't need any sunlight or UV rays to get hit and do any other activity on your surface. But then what happens is that the angle between the contact of droplets of water or the rain to the surface where it is going to hit, or where you have the easy to clean surface, the angle is going to decide how well your surface is going to clean up. If it is going to be a complete droplet, then it is just going to wipe off all the dust away from it. So these are cleaning aspects here. So next we are going to see about solar control. So in solar control, the first is going to be the thermal insulation panels. So here these panels are going to help in reducing the amount of thermal radiation which is going to enter into the space through your surfaces. So these are vacuum insulation panels. So these panels are ideal since it is going to be very, very thinner in its section. So while comparing to the conventional insulation, this is going to have a very good effect. So these are vacuum insulation panels. So these panels come in standard sizes, and you cannot drill it, you cannot cut it. If you do anything, then the insulation effect will get reduced. If you want, you can customize those insulation panels and get used to your building envelope. So this can be laid on your floor, on your walls, and on your roofs as well. So next is thermal insulation through aerogels. So these aerogels are again a very high performance thermal insulations. So here the basic item is going to be aerogel. Again, aerogels are the very, very lightest form of materials that was invented so far. So this is very light and airy, and the weight that is going to weighted by these kind of insulation is going to be very, very less. So these are thermal insulation aerogels. This is the aerogel, and this is how it is going to get packed. Next is temperature regulations. So here we have PCMs, which are phase change materials. So these are passive temperature regulations. Here you can control the temperature, either it is going to be heating or cooling. Both these demands can be controlled using these phase change materials. So, for an example, if we take water, and while the water gets freeze below 0 degree, and that is a phase change, and you cannot see it directly. So, latent effect, latent heat is another important physics that is going to be there using in these kind of passive nano material usage. So here, this phase change material you cannot see directly through your eyes, just as the latent effect. You cannot see how water is directly getting converted into ice when it just goes drop down below 0 degree, and there is a huge amount of energy which is being used during the phase change, which eventually is not at all seen. So that is how this works. So while we have the temperature from heating or the same space have to be cooled, it can withstand both. So it is going to get heated up and loosen up, or it is going to get solidified to reduce the cooling demand. This is how these phase change materials work. Next is the solar protection. So solar protection again is going to be helpful to the glasses. So here the glasses gets darkened automatically, and there is no need of constant electric current to make this happen. So glass is going to be the future. If that is going to be the case, then these kind of solar protection have to be used, so that the amount of heat that is going to enter into your space is going to get reduced. Next we'll see about air purifying. So we have a lot of pollutants and odors which are like around us. So here these are going to get broken, and it will just disappear. So these broken particles are not going to be harmful again, while we compare to the actual pollutants and odors which are going to affect the indoor air quality. So this is going to help in improving the air quality. So this does not mean that it is going to replace the ventilation, but this is going to help in just improving the indoor air quality. Not only indoor, even it can be used in the outdoor surfaces, so that the outdoor air quality also can have a very good impact. So this is not going to completely purify the air. So the air quality again is going to get increased. So this can be used where you will have a lot of industries, and where you will have a lot of industrial pollution happening. So this is that kind. Next we have the fragrance capsule. So what happens with the fragrance capsule is that these fragrance capsules are very, very minute capsules, which is going to get embedded within a very thin permeable membrane. So this actually works on release on demand principle. Say for an example, we use carbon papers. So while we use carbon paper, we just keep it and give a pressure over the carbon paper, and we write it. And whatever we write, the amount of carbon that is being inlaid on the carbon paper, it is going to get impressed on the paper which is being kept below. The same typology is going to be used in fragrance capsules as well. So this can be used, say for an example, in sofas, where if you go and sit somewhere, the fragrance capsule just broke down, and you will have a very good fragrance. That can be used in carpets, and these are few areas where it is effectively used. You need pressure to release the fragrance out of the capsules. So it is less used or less effective, say for an example, in wall paneling. If you have pressure, then it is going to get a very good effect on your environment. So next is fireproofing. So fireproofing is again an important category where nanotechnology have a very good impact. So here the fireproofing material is going to be highly efficient, and this is again going to be very light, so that it is not going to have a very heavy, it is not going to be a very heavy material. So these materials are like sandwich panels. So you will in fire safety glasses it is used widely, and the material is going to get sandwiched between two glasses, and the nanomaterial is going to provide a very good fireproof for your building. Then the UV protection. So UV protection is again going to be the future demand. You have to get yourself protected from UV rays, which is a very harmful rays, and it is not harmful only for the human beings, but also it is harmful for all of the materials that are there around us. So here the image which shows the microscopic image of UV absorbent material, which is laid below a glass material with a varnish coat over it. So usually titanium dioxide, zinc oxide, and sir oxide are well suited for this particular purpose, where it says that it absorbs UVB rays. So this is going to absorb all the UV rays and protect yourself from the radiation. Next is anti-fogging. So anti-fogging is essential where you have a lot of moisture which is going to settle on the surface in the form of droplets, and which where all the droplets is going to get combined into one particular layer and forms cloud-like surfaces. The water particles is going to form a thin film, and that particular thin film is not going to hide your view, but then this titanium dioxide is going to help you in reducing the fogging up quality and improving the clear vision. So next is the anti-reflective coatings. So anti-reflection is used where you have a huge glass plane and you have a lot of reflection that is happening due to the glass plane. So the anti-reflective coating will improve the solar transmission, but at the same time is going to reduce the amount of light that is going to get reflected out of your surface. Say here you have a photovoltaic module which is having anti-reflective coating on one side, and the other area is not having an anti-reflective coating. So it is reducing the amount of reflection that is going to happen due to your surface. Next is scratch proof and abrasion resistant. So this is going to improve the scratch and abrasion resistant. You will have a transparent coating which is going to be very durable, and this is going to help you in that. Generally materials will have wear and tear or friction or abrasion which is happening to the materials. We cannot avoid that. For that there were like two basic principles which were ideally used. One is self-healing layers, which were very common in concretes and other ceramic and glass layers. And the other is going to be scratch proof, glass like hard materials which are scratch resistant. So apart from this, there is tribology, which was a weak terminology from tribos, which called as friction. So nanotechnology can help you in reducing the amount of friction that is going to happen between your surface. Okay, next is the anti-gravity. So these are permeable surfaces with permanent anti-gravity coating, and these are hydrophobic and dirt resistant as well. So what happens is that if we want to protect our building, anti-gravity coatings are essential. So either the building's coatings, if we have any other coating on the surface of a building, it is going to completely close all the pores that are there in the surface. which will resist in providing a good anti-gravity. So what happens here is that there is a very thin, ultra thin layer is going to get applied over your surface, which will which is not going to close any pores. You will have the capillary effect, and also it is going to be hydrophobic in nature, and that's how these graffiti effect is happening. And the image which is shown here is the historic monument of Berlin, so which is completely coated using anti-gravity. So next is antibacterial. So antibacterial, again, bacteria will get targeted directly, and it will get destroyed. So these are very effective in hospitality related areas. So this is called like even more effective than your antibodies. So these antibacterial effects are even more stronger than the antibodies that is what we use. So next is anti-fingerprints. So again, wherever we use glass, wherever you have ceramics, anti-fingerprints are a very, very problematic thing, especially on doors, handles, in steels, everywhere. So here, these anti-fingerprints is going to completely remove all the prints. It means you cannot see any visible fingerprints directly. With this, I'm signing off, and thank you so much for listening to this presentation.